Okay, today we will be solving some word problems involving HCF and LCM. So the first question is this one written on the board. Using Euclid's division algorithm, find the largest number that divides 1251, 9377 and 15628, leaving remainders as 1, 2 and 3 respectively. So same thing here. Let this number, the required number, let the required number be x. We take it this way. So that means Euclid's division algorithm, we have to find the largest number that divide these three. Okay, that means when I divide 1251 by x, some quotient, and the remainder will be 1. And next number 9377, again when divided by x, some different quotient, and the remainder is this 2. And the third number 15628, when divided by x, it leaves some other quotient and the remainder is the third one, 3. So this is the situation. So we have to find x. This is the largest number. When it divides this, leaves remainder 1. When this number when divides this, leaves remainder 2. And when this number divides this, leaves remainder 3. So that means this x cube will become this minus this. X cube is equal to 1251 minus 1, 1251 minus 1, that is 1250, and x cube dashed from this 9377 minus 2, so 9375, and from this x cube double dashed is 15628 minus 3, that is 15625. So that means x is the common factor of these three numbers, and obviously this is the highest common, because it is the largest number, so this x will be the highest common factor. So this x is nothing but, so therefore x is the HCF of 1250, 9375 and 15625. So this we have understood the question, and we also have found out the way how we'll solve the question, that we have found. So now this thing you know how to do by Euclid's division algorithm. First you'll find HCF of any two number, then we'll find HCF of the third number and the HCF of the first two number, that we have shown you in the previous class. So you divide 9375 by 1250 for finding HCF of these two number, 9375 and 1250. By Euclid's division algorithm, we will be doing the division. So what will be the quotient that you can do by doing rough? I think it will come out, the 7 will be the quotient. 7 will be the quotient, and if I multiply this by, it will become 8750. 8750. You can do yourself. So how much it is? 625. Yes. So we divide the divisor 1250, and it is 2. It will go by 2. So 1250. So the HCF is this one, 625. So now we have to find HCF of this 625 and the third number. So x is equal to HCF of these two came out to be 625. So 625, 15625. By the same method, divide the bigger number by the smaller one, and it will go, if you do the division, it will go by 25. It will go by 25, so you will get this. Okay. So this is the HCF. And therefore x is equal to 625. So answer is this, that is 625 is the largest number which divides this and this, leaving remainder 1, 2, 3 respectively. So in this way we solve this kind of question. These are very big numbers, so here that's why they told to do by Euclid's division algorithm. Okay, so there are similar kind of questions we will be getting in your any side book, so you can do this kind of question for your practice. Okay, so it's okay. So basically we are subtracting the remainders from the numbers, this from this, this from this, and this from this, and the numbers that we get will the we have to find the HCF of these three numbers, and that will be the required largest number. Okay. Now next, another kind of question. So the next question is this one. There is a circular path around a sports field like this. Circular path. Okay. Sonia takes 18 minutes to drive one round. That means if she starts from here and goes in this way, so for completing one round, Sonia takes 18 minutes. While Ravi takes 12 minutes for the same. That means when Ravi also starts from here and makes one complete round, he takes 12 minutes. These are given to you. Okay. So these are the times taken by Sonia and Ravi for completing one round. Okay. If they both start at the same point like this here, they started from here and at the same time and go in the same direction, both are going in this clockwise, both. After how many minutes will they meet again at the starting point? So this is the starting point, okay? So you see, Ravi is faster, he takes less time than Sonia. So obviously, when Ravi will complete one round here, Sonia will be left behind, she will be here. So in this way, as they may take rounds, the difference between them will go on decreasing, and at a certain time, both of them will be again here at the same starting point. So you have to find after how many minutes will they meet again at the starting point. That is the question. So what is asked to find, we take this as a variable. So let after x minute both Sonia and Ravi meet again at the starting point. So whatever you have to find, we take this as an unknown variable. Then it will be very easy to formulate the solution. So you see, now this x minute. So in x minute, both Ravi and Sonia are completing rounds. They are here at the starting points. So that means what? That means x has to be multiple of time of Sonia's one round. That is 18 minutes. 18. And as well as x also has to be multiple of Ravi's time of completing one round. So that is we observe. Okay. So this x has to be multiple of both 18 and 12. So obviously this x has to be common multiple of these two numbers. And since we have to find after how many minutes they will meet again, that is the least common multiples. So they will be meeting many times here. But we want the minimum time, so that's why we need the least common multiple. So therefore, x will be equal to least common multiple of 18 and 12. So that's why in this way you have to understand whether it will be LCM or HCF. So whatever you have to find, if this is factor of, if these things you have to understand, if this is factor of the numbers given, then we take HCF, and if they are multiples of the numbers, then we take the LCM. Okay. So now these numbers are very small in size, so we'll do their prime factorization. So 18 is equal to 2 into 3 square, 9 2 is 18, and 12 is equal to 2 square into 3, 3 4 is 12. So what will be the LCM? LCM is the, what is the common factor? 2 is the common factor. So we take the bigger power. So I'll be taking 2 square when this 2 will be included here. So this is 2 square into, and again this is another common factor. So I'll take the bigger power, this one, and this will be included here into 3 square. So it is 4 into 9, so 36. So answer is after 36 minutes they will meet. So this is another type of question. So you have to understand the question. In this word problem, you have to visualize the situation, what is the situation and what are given and what we have to find out. And you have to think whether these are factors or multiples. So in this case, this is LCM of these two numbers. Understood why they are LCM, that I have explained. Okay, I think you have understood. So you can do the word problems from your side book. And you'll be getting these kind of problems we'll be able to solve, I think. Okay, now this was very straightforward. I've been showing you the concept why I'm taking LCM. Now let me explain some more problem which are not that direct. Okay, so next question. Next question is that what is the least number? What is the next question? What is the least number divided by all 585, 390 and 375 when 150 is subtracted from each number? So that means what? When 150 is subtracted from these three numbers, we have to find those numbers first. So 585 minus 150, you have to find out. Then 390 minus 150, and the third number 375 minus 150. So the numbers that we'll be getting, so what you have to find? The least number divided by these three. So what are the numbers? Let me find out the numbers after subtraction. 435, 240, 435, 240, and last one is 225, I think. It is 225. So what you have to find then? We have to find the least number divided by these three. That is the question. So that you know, that means what? That least number has to be common multiple of these three. These three has to be multiple of this. So it's a least number, so it has to be least common multiple of these three numbers. So the required number is LCM, least common multiple of 435, 240 and 225. Okay. So we have to find out the prime factorization of the numbers 240 and 225, and from that we can find out the LCM. So the prime factorization of 435 is your 5 into 3 into 29. 3 into 5 into 29. You can do yourself, and that one is 2 to the power 4 into 3 into 5. 2 to the power 4 into 3 into 5. And last one is, it is 15 square, so we can write 3 square, 5 square. 15 is known number, 3 square into 5 square. So these are the prime factorization of these three numbers, which are obtained by subtracting 150 from each numbers. So therefore, LCM will be common factor 3, highest power is this one, so this will be coming here. So 3 square, 2 no common, and then 5. is the highest power. So these will come here, this will come here. 5 square. So what are the factors left? These 2 to the power 4 and this 29. These are the left out factors. So you multiply this and you get the LCM. The answer will be, after multiplication, the answer, okay. So okay, here I'll show you the, because it's a very big calculation, so I can show you the calculation technique. So 9 into 25 into 2 to the 4 is 16 into 29. So you can group, look at, because when I multiply 25 with 16, what will I get? We know 25 into 4 is 100, all of you know. So that's why there are 4 into 4. So from this I'll be getting 400. 400. So 9 into 400 and this 20 into 29. 4 9 is 36, 3600, and this 29 can be written as 30 minus 1. Okay. So these calculations, you see, 3 zeros, 3 6 are 18, 3 these are 9, 10, minus 3600. And by subtracting, this is very, so you don't have to, in this way you can manage the calculation. You see, by observing the factors which can be taken together so that I get multiples of 10. This is okay. In this way I can do. And this subtraction is easy. And the answer will be 1044. So this you can get it. 10, so 4. This 10 minus 6 is 4, and you can do the calculation. 8 minus 4 is 4. 0. I think this is the answer. 10. Yes, 104400. Yes, this is the answer. Answer is 104400. And here I have shown you the calculation management also. Observe the factors which can be taken together so that my calculations become simpler. I have not done any rough work. I can do in this way. So this is a question where LCM is done. If I found out, okay. Okay, pause. Next question. Write the least number which will be divided by 24, 15, 30 if increased by 11. So again, we take the number that we have to find as a variable x, unknown variable x. So let the least number, required least number, let me write required. When I write required, then all the condition in the question will be included. Let the required least number is equal to x, that we have to find out. So according to the question, you see, and the least number which will be divided by all these three if increased by 11. That means if I increase this number by 11, that means if I increase the number by 11, then this number will be divided by all these three. That means this number will be common multiple of these three. Is not it? So since this is least number, so this number will be least common multiple of 24, 15 and 30. So this is the main step that you have to understand. So if I assume the number that we have to find as a variable, then very easily we can formulate our solution in this way. So we'll find it out separately. So 24 prime factorization, 2 cube into 3, 3 8 is 24, then 15, 3 into 5, and then 30, 2 into 3 into 5, right? So what will be the LCM of this? So x plus 11 will be, LCM kya hoga? The LCM will be, highest factor is 2 cube, then 3, 3, 3, another common factor, then 5, 5. Sorry, only 5. 5 is, no, since this is not in the common factor, okay, this is okay. It's okay, this is the 5, these 5 I have taken and these 3 I have taken, these 3, okay. So this is what, 8 into 3 into 5, so it is 120. 120. So x plus 11 is 120, therefore x is equal to 120 minus 11, so it is 109. That's the answer. So the number is 109. Okay. Next question. A mansion has to fit a bathroom with square marble tiles of the largest possible size. Okay. And what would be the size of the tile required that has to be cut, and how many such tiles are required? So this is the bathroom, okay, whose length is 10 feet and the breadth is 8 feet. This is the bathroom floor area. So now, so square tiles, it will be something like that. So tiles like this, okay. So these are the tiles, square tiles, and let A be the size of the tiles. So these are the things, okay. Let A be the size of the, here it is in feet, so a feet, size of the tiles, square tiles. Then the side of the square has to be factor of this 10 feet, because out of this 10 feet, this side of the square has to be cut out. So this A has to be factor of 10 feet, as well as this is A, this is also A. So this A also has to be factor of this 8 feet. So therefore A has to be, because I need the largest possible size, so A has to be the highest common factor of the length and the breadth of the floor of the bathroom. This is clear, no? Why A has to be HCF of this length dimension and breadth dimension, that is clear, because the sides of the tiles has to be factor of this length as well as of the breadth. That's why. So that we can find out with very small numbers, by prime factorization we can find out, and 8 is equal to 2 cube. So therefore the common factor is 2. So it is 2. So the first part of the question is answered, that is what is the size of the tile. Therefore A is the size of the, therefore size of the tile is 2 feet, or which is equal to 2 into 12 inches, that is 24 inches. 24 inch is the size of the square tile. Now next part we have to find the number of such, how many such tiles will be required. So number of tiles, very easy. One tile, each tile takes an area of A square. So we divide the whole area of the floor by the area of the each tiles. Then we get the number. Therefore the number of tiles required will be area of bathroom floor upon area of each tile, that will be the number of tiles. So now what is the area? Length, this is a rectangle, so length into breadth is the area of a rectangle. So length is 10 and breadth is 8. So this is the area, and area of each tile A square, that is, it in feet it is 2, so 2 into 2. So 4 2s are 8, so it is 20. So 20 tiles will be required. That is the answer. So size of the tile is 24 inch and number of tiles required will be 20. So there is also again a concept based question. So you can understand the answer, solution is very easy. Okay. Next question. Color pencils were sold in packs of 24 each and crowns in packs of 32 each. If you want full packs of both and the same number of pencils and crowns, how many of each you need to buy? Okay, so the question, what does the question say? The question says that now there are, you see, color pencil packs are there, color pencil packs, where each pack has 24 like this, and crown, in crown there are 32 in crown like this. Now we have to buy full packs of both and same number of pencils and crowns we have to buy. That means, so let X crowns and X color pencils are bought, because you have to buy same number of pencil and crayons. So X crayon, then X pencils will be buy. So now what will be the value of this X? Because there we have to buy in packs. So a group of 24 we have to buy, and again a group of 32 crayon we have to buy. So obviously this X has to be a multiple of both 24 as well as of 32, because we have to buy the in packs. So therefore X will have to be the least common multiple of number of color pencil in a pack and number of crayons in a pack. In this way we can find out. Okay. So is this clear? Why this has to be LCM, least common multiple? You have to think, then you will understand. Okay. So let me find it out by prime factorization. It is again 2 cube into 3, and 32 is your 2 to the power 5. Okay. So therefore the LCM X will be, what will be X? So X is, the LCM will be, highest power is 2 to the power 5, and this factor is left 3. This is included here. So it is 32 into 3. So it is 32 into 3. No need of multiplying. We keep it in this form. You see why you don't multiply? Because what you have to find? We have to find how many of each you need to buy. That means we have to find number of color pencil box, color pencil packets, and the number of crayon packs. These we are actually have to find. So these 32 into 3 crayons will be bought. So therefore number of crayon pack will be, how many crayons we are buying? We are buying X crayon, that is 32 into 3 crayon is the total number of crayons you are buying, and you are buying in a cluster of 32. So group of 32. So that's why you see, that's why dividing by 32. So you see no need to multiply, because this 32 will be getting cancelled. So 3 packs of crayon will be required. So that's why don't multiply, remember, this will be getting cancelled. That was not the final answer. The final answer, the number of crayons pack and number of color pencil pack. So similarly, number of color pencil pack will be, total number of color pencil, again same, 32 into 3, 32 into 3 divided by how many in a pack? 24. So divide by 24. So 3 8 ja 24 and 8 4 ja 32. So it is 4. So the answers are like this. Number of color pencil is 4 and number of crayon pack is 3. These are the answers. So these things you have to understand, and that's why don't multiply. That is the important point. We can save our time, we can save our labor, because they will be getting cancelled. Okay, that's all.